Hello there. In today's video, we'll be looking at solution to lab 7 and lab 8. All right, in lab 7, the scenario is to describe this hypothesis by Collat, and we've been given the hypothesis that has been described there, and we have like 5 different steps. The first is to take a non-negative and non-zero, meaning a positive integer that is greater than 0, and name it as CO. Okay, that means we have a variable name called CO. And then we have a condition here. If it is even, evaluate a new CO as, that means CO will be equal to CO divided by 2. Okay. Otherwise, definitely this is another condition, or yeah, definitely another condition. Otherwise, if it is odd, evaluate a new CO as 3 times this and that. Okay, so but then if CO is not equal to 1, then skip to point 2, which is this point 2. That means repeat from here again all through to this point to point 4. Check again if CO is not 1, repeat all this. Oh, this looks like a while CO is not 1. I don't know if you are seeing that already. This point 4 already look like why CO is not 1. Go back to keep doing 2 and 3. Check again. Why CO is not 1, go back to do that again. All right. So we have an idea of what we want to do already. All right. Now, regardless of the initial value of CO, it will always go to 1. Okay. Meaning that our end value, it should always end at 1, regardless of whatever initial value we've started with. Remember, our initial value is a non-negative number, definitely a positive number, and it is greater than 0. All right, so we have to write a program that reads one natural number and execute the above steps as long as CO remains different from 1, just like this one. We also want to count the steps needed to achieve the goal. Your goal should output all the intermediate values of CO. All right. So the hint is that to which is one of the most important things that we should look out for, which is here stated in the hint, is that is to transform this Collat idea into a while loop, and this is the key to success here. Okay, so let us go to our code. I think we have a skeletal code. Yeah, I don't know. Okay, there is no skeletal code actually. We have just the test data, input 15, 16, and 1000. Okay, so we'll just go right about that. Okay, so here in our code, let me clear this out. Let me change my directory. Okay, so right here in our code, what do we want to write? Remember, we have a question there, and this is what we have there. Okay, so they're asking us to do a bunch of things there. All right, so I think we should just start off with the very first thing that they've asked us to do to collect this value, CO. Remember, so that it would definitely be CO would definitely be an integer, but we are going to be imputing that integer. So we impute something, then change it to an integer. So let us say that enter a non, just the same way they've mentioned there, a non-negative and non-zero integer number. Okay, all right. So, well, in our code, there is this thing that they've mentioned there. If you'd notice, they said that so we should count the steps needed. So when you are treating a question, please be sure that you've read through all the information. Count the steps needed to achieve the goal. Now, also, see this is another goal here. Should output all the intermediate values of CO. Now, we've done one. We've read one natural number, 1. Now, the next thing is to do all of this. Remember, all of this will be in a while loop. Then while we are doing all of this, we need to be counting the steps each time the while loop will run before we eventually get one as our final answer. Then once we are done, we should now print out the output of every value. All right, so let us go back to our code. So I think so because we want to be counting step or the numbers of step that we would take. So I can just name a variable and call it step. Let me call it steps. I don't want you. I don't want you. Steps. That's automatically imported. Okay. All right. So now I think we can start our while loop. If not, we can definitely come back here to change. Now our while loop is definitely around YCO. No, they've mentioned it. YCO is not one. I think you can see that already from what's it called? From this point 4. That's where our while loop is. Always do that while loop from point 4. All right, so we are saying that YCO is not equal to. So how do we represent our not equal to? This is how we do that. Remember, it's not equal to 1. Then we can then go to point 2. What is point 2? If CO, no, to get if CO is an even number or an odd number. So if CO is even, so evaluate a new number. So if is even, do the CO is equal to CO divided by 2. So how do we achieve that? Remember, even numbers are numbers that are not that are divisible. Even numbers are numbers that are divisible by 2. 4 divided by 2 give us 2 whole number, no remainder. So if you have anything like this, CO mode 2, and it gives us 0, it means that that is a number that is divisible by 2. And any number divisible by 2 is an even number. So if it is an even number, they said that we should do something. They said that CO should be equal to C0 divided by 2. But remember, I've shown us something before now. So I think some of you can guess already. So we can also write this as CO divided equal to 2. Who sees that? This here is still just exactly like this. Remember, we've done this where it was plus. So we said that if you're adding the same number by another thing, instead of writing it explicitly like this, you can just write it like this. This is exactly the same thing. So I'll leave this here for now like this for you to see and just to get familiar with that concept actually. All right, so the other one is now if, which is step 3. If otherwise, they said otherwise. So otherwise looks like something like else. So if CO is odd number, obviously if a number is not an even number, it is definitely an odd number. So we just go straight to CO is equal to 3. Then they say multiply by CO plus 1. Right? Now we need to, we've done this, we've done the evaluation from step 1. We've done step 2, we've done step 3. Now, step 4 is to keep checking, which I think we have done. Okay, yeah, is to keep checking. Okay. So, but then before we can go back to check again, they says that uh, we should count the number of steps needed. So it is even the steps. Yeah, so we need to count the number of steps that are needed. And how do we do that? So let us say that one should not be hard. We can just say steps should be plus equal to 1. I believe you understand what we did there. We did steps is equal to steps plus 1. All right. Okay, so I think we are good here. Very good. But then, one more thing. They said that we should output all the intermediate values of CO. Do you see that? Now, to print out all the intermediate value of C0, it means that whenever in this if statement here, once we are done with whatever processes that are here, we should print out the value of C0. That means when we divide C0 divided by 2, whatever answer you get here, print it out. And if the number is not or even, if it is odd, 3 times C0 plus 1, whatever you get, print it out too. So I can just put my print statement here. print, we are printing an integer value. Do not forget, because in the even number part, it's going to give us um yeah, he's going to give us, anything. Remember when we were treating operators, whenever you divide, it gives you a floating point number. So I think here this should be fine. And what is our final thing to do? Okay, so I think that's all for now. Yes. Okay, so okay. They said we should count, we should show this total number of counts that we have counted. We need to just show it that, so this is how much step it took for us to get to the final value. So we can just go outside of the while loop and print the final step. After you are done with the whole of this while loop, you can just print out the numbers of steps you take to get your final answer there. All right, let us save our code. Let us run it. All right, so we're expected to input, enter a non-negative value, blah blah blah. All right, so we have this guy. I think, yeah. So we should try with 15. You should print all this on a straight line like this. That is 46, 23, 70, 35, like that on a straight line. All right, let's try that. 15. So let us input 15, enter. Yeah, so what's our first value? 46. Is that correct? Yeah. Okay. Yeah. Think that's cute. hmm Okay. So we have all of that. Then when we go to the next guy there, we have okay. So when we use 16, when we run the code with 16, we should have four values: 8, 4, 2, 1. And when you run with what's the last value there? 1023. With 1023, you should have a whole lot of things. And yeah, the step should be 62, really. So let's confirm if step is 62. Yes, the steps are 62. All right, so let us go to the next one, which is our label voweliter. All right, so for voweliter, what we are checking for here is just it's just to use for loop and conditional statement if else, then continue statement. Okay, so what's our program? What should they do? Your program must ask the user to enter a word. Okay, use user word and equal to user word dot upper to convert the word entered by the user into an uppercase. Okay, then we'll talk about the so-called. So yeah, definitely we'll still talk about this string method called upper. Okay. Anyways, but what this does is to convert. If you type in any small letter words and you save it inside user word, it changes it to uppercase. All right. So we are to use conditional execution and continue statement to eat the following vowels: A, E, I, O, U from the repeated word. Now, I assign the uneaten letters of the wo- of the wo- of the assign the uneaten letters to the word without vowels variable and bring the variable to the screen at the end of it all. So what is the skeletal code? We have word without vowel. Yeah, this is where we want to be saving this particular line, this last line. Any word that is not eaten, that's where we want to save it. We want to save them inside here. Then prompt the user to enter a word, assign it to. Okay, let's just write out this skeletal code, and you know what? Let's just jump right into it. Let us jump right into it. Okay, just one more. All right. Where's our code? Let's type this out. Okay, which one do you want to put there now? So I'm trying to, I don't know where this guy went to now, but trying to bring it back. Just a moment. Okay, for some reason I can't find it. Yup, it's up. So we type this out, word without vowels. So just let me have that typed out. Why not just make it smaller? Okay, I think that should work. Yeah. Then we are prompted to type in some things, okay? Okay, so we've been asked to enter a word. Then apart from that, we are then assign it to the user word variable. Okay. All right. So prompt the user. So definitely we are working with strings here. So we are not going to be converting whatever thing we are imputing. So just collect an input and call it enter word. Enter a word. Okay. So then this word we are going to convert it. Okay. So they've given us how to do that conversion anyways. And they said that we should do it like this. User word dot upper using this method. Then I think for letter we have this for letter in user word. Okay, so yeah, complete the loop. Let me just shorten that and okay. So once we are done, we should then print the assigned word. Okay, the assigned word. All right, so let's see. So to complete this loop now, definitely from our to complete that loop, so it's just to write these conditions here. Using okay, we are done with that. So it's here using this conditional execution, if statement and continue statement. Then any word, whenever we see a or e or I or o or u, we should just eat it. All right. So that means we are not going to save. We just keep skipping them. All right. So let us go back to our code. Let us see that we can start with our. It seems a condition. We can't use while here, and the reason why we can't use a while loop is because we the condition we are checking for is not the same every time. It's changing. So continue means that if the word is a, which is a vowel, don't put it inside this word without vowel. Just keep it. That's why we did continue. So just go to the next word, which is this letter will be iterating through every word. All right. So let us go to the next word, and this time we are still checking for another. What's it called? So and again, if you notice, I'm using another if and not else if. The reason why I'm not using else if is because we want to ensure that we are checking for every of these words a e I o u. We want to ensure that a e I o u is not checked at all. And if we should use else if, what it does is that for that particular letter, it would check for that particular letter only. Once it sees that that particular letter exists, it would only do the instructions and it won't check further anymore. But in this case, we want to ensure that we are checking every for all the words. We want to check through all the words, every of them. So that's why we are using another if instead of elif. So okay, we'll just go through that again and say elif. Oh, sorry. This place should be double equal to. Sorry, double equal to. We are comparing, not assigning. Capital E. Then again we are to continue. So another if, and to continue. Remember why we are continuing is just to go to the next iteration. Meaning go to the next word. We are not interested in checking any other thing again. Okay, so yeah. So somebody is asking that what if we use elif? Yeah, sure, you could use elif. Really, you could even try it out and see what's and see the result. Yeah, you could try elif out and see the result, and yeah, let me know what the outcome is, and finally else. In fact, okay, just to be for you to be sure, let's just for you to be sure that elif 2 works. Uh, so we just use elif straight up, and okay, then else finally word. So I don't know if you get what we are doing here. Remember, we said in strings operation when we were taking strings, we said you can add strings together. So remember, this is a string here, an empty string, nothing is inside there, and letter is also a string because we are looping through all the letters inside that we've collected, which is a string. So when you do string plus string, remember what this is. Let's represent word without vowels as W. W is equal to W plus. Let's represent letter as L plus L. That's what this does. So what this does is whenever you have a plus, whenever you are adding a string plus string, what it does is it joins that string together. So what this means is an empty string plus whatever thing is in vowel makes that new letter. So we have to print the assigned word. I think we are done there. So we can just print word without vowels. All right, let's try to run. I think we have. Oh, no test data. Okay, let's just try with some random words. Let's see. Vowel. Let's try vowel. So if I run this word with vowel, so we are expected to see, nothing with A, I, O, U. We are expected to see V, W, L. So, all right, let's see. And yes, we got V, W, L. All right, let us check with something else. Lab, we are expected to see LB. Yes. Let's try with Gregory. Gregory. So all this AEIU should not be there, which is also correct. So yes, you can do this with AEIOU and we are good. I think yeah. So that is all for here, and let's wrap this up. So I think in the next video we can look at more examples, and if we would not be looking at more examples, so to what we've learned so far, then I think we'll just be moving on to data structure where we'll be learning lists, tuple, dictionary, set, and yeah, and like. All right, do enjoy yourself and see you in the next video. Peace out.